Hi, welcome to Exam Debug. I'm Chris, and today I'm going to be taking you through one of the exam papers. So this is paper 1, which is the theory paper, and it's for the year October, November 2011. Oh yeah, and of course it's for the ICT paper for IGCSE. So if you're interested in working through the paper with me, then please stay tuned. Welcome back. So let's get started. So the first question we have here is number 1. Name the methods used to represent information on A, B, C, and D using words from the list. So this type of question comes up at the beginning quite a lot. It's a nice, easy question for us to start with. But the trouble is, there's a lot of memorization. There's not a huge amount that we can work out unless we already know the parts. So let's just go through this one very quickly then. So A here, we have this black part, which is part of a bank card. And if we look down here, we can see that this is going to be a magnetic stripe. Copy that in there. And I'll put a difference just to make it clear. So A, magnetic stripe. The next one, you can see we're looking at this front part of the bank card. So this gold section here. So this is a gold chip. And again, we can find the chip down here as well. Like I said, there's not too much going on here. We just basically have to memorize this section. Part C, this appears to be an exam answer question where you use your pencil to mark off what answers you have. So this is going to be read in using an optical mark reader, and so these are optical marks. Optical marks. And finally D, hopefully you'll all be familiar with from daily life, is of course a barcode. So those are just some nice, easy marks to get us started with. Again, if for some reason you don't know what something is, one strategy to perhaps help you would be to go through a process of elimination with whatever is left. I mean, if you know what a graphics tablet is and you know it's not one here, you can score that off, and then whatever options you have left, just make a guess and do the best you can with that. Right, so let's move on to the next question. So ring 2 items which are output devices. Again, so nice easy marks for us. We just have to circle 2 of these that are output devices. So specifically, what is an output device? It's something that's going to give us information out from the computer. So it's something that's passing it from the computer to the user, perhaps outside. So as opposed to an input device, which is for us to input data into the computer. So if we have a look here, we can see we've got a buzzer, graphics tablet, joystick, monitor, optical character reader, and a webcam. So which of these things are giving us things out from the computer? Obviously that would be a buzzer, which is giving us out sound, and a monitor, which is giving us out light, I suppose. The other ones, graphics tablet, you're going to be inputting, joystick, you're inputting signals, optical character reader, you're reading in papers, and webcam, you're reading in images. So these are all for input. Okay, next question 3. Tick true or false next to each of these statements. So computer programs are examples of hardware. An internet browser is an example of software. A pointer is used to select items in a command line interface. A PDA is larger than a desktop computer. So we just need to go through these and say true or false. One of the most important things here is that you always put an answer. So even if you're not sure, you get a 50-50 chance, tick true or false and go for it. So first one, computer programs are examples of hardware. Again, this is just a simple knowledge question. Hardware and software, do you know the difference? So hardware are physical aspects of the computer, and the software ones are the non-physical, so the programs inside the computer. So computer programs are examples of hardware, so this is going to be false. An internet browser is an example of software. So again, we have to know the difference between hardware and software. An internet browser, as I'm sure you're aware, is not a physical thing. It's just a conceptual idea on the computer. It's a program. So an internet browser is an example of software. This is going to be true. Next one. A pointer is used to select items in a command line interface. So this is getting into different types of interface. So what I'm using here on Windows is a graphical user interface. So I've got nice pictures and things like this to select from. So windows, icons, menus, pointing devices. So a command line interface is not like that. A command line interface looks like this. And so we can do different things and move around using only text. So in answer to this question, a pointer is used to select items in the command line interface. So the answer is going to be false, because command line interface, a graphical user interface is one like Windows, the one I have here, which has a mouse and pointer. So that's false. And finally, a PDA is larger than a desktop computer. So again, it's a knowledge-based question. A PDA is a small personal digital assistant, I believe, and is a small handheld computer, maybe more similar to modern day smartphones. So are PDAs larger than desktops? So a desktop would be the type we see maybe in your school or your office, where you have a large systems unit. So the answer is going to be false as well. Okay, let's have a look at the next one. Okay, so we're still on these fairly easy questions, and it's a lot of just matching up and knowledge. Don't worry, the test gets more interesting and harder as you go along. So anyway, complete the following sentences using the most appropriate device from the list. So again, we just have to have a certain amount of knowledge here. So a remote control. Yeah, I'll do it as A, B, and C again. Sorry, so let's try that again. Is used in recording of voices for presentation software. So which of these devices is used for recording voices? Of course, it's going to be a microphone, which is an input device for sound. Okay. Is used to control a multimedia projector. So again, what's a multimedia projector? For presenting projects, you might have seen it, it pushes the light onto a wall or a pull-down screen, so projector. How do we control this? Usually they're high up, at least in my classroom they are, and so we would use a remote control, or we could go manually with the keypad, but that's a bit tricky, and the keypad's not on the list there, so it has to be a remote control. Is used to write a letter. Again, we just have to look through our list here. In this case, what do we use for typing? feasibly a graphics tablet, but obviously keyboard is the most sensible answer. So that's one thing you've got to watch out for throughout the test. You're not just picking a right answer, you're picking the best right answer as well. D is used to read information from a bank card. So as we've seen earlier, in this one here, bank cards often come with chips. So in this case, we would need a chip reader in order to read the chip that is on the bank card. And A, B, C, D, E, 1, 2, 3, 4, 5, 6. Okay, yeah, so we've got one extra. Is used in a flight simulator. A flight simulator is for perhaps training pilots. So pilots go in and they have to fly the plane. It could also be on your home computer. A lot of people have flight simulators there because they were really popular for a long time. And to control this, our options left are a joystick or a graphics tablet. So in this case, our answer is going to be a joystick, which is an input device for controlling movement. Okay, so again, you just need to make sure you have memorized a lot of these things. So on to question 5. Question 5 is where things start to get a bit more difficult, but also a good deal more interesting. So describe the role of a proxy server when a LAN is connected to the internet. So this is going to be worth 3 marks. So make sure you keep an eye on how many marks each thing is worth, as it will help you know how many points you should give in the answer. So first of all, we have to understand 2 things here. What is a proxy server and what is a LAN? So let's start with the easy one, which is a LAN, which is a local area network. So this might be, for example, a school network. And then the proxy server, which is a bit more complex, is like a middleman between our local area network and the internet. So let's say, for example, I'm at my computer and I want to go to Google while I'm at the school. So what will happen is I will send a request and it won't go straight to Google. It will go to the proxy server. The proxy server will in turn go and request on my behalf to Google. Google will send the web page back to the proxy server, and then the proxy server will send the web page back to me. So why would we want to do something like that? So the main reason, at least in our school, is for protecting the students. So we want to make sure that the students can't access websites which are, let's say, undesirable. So what will happen is a student will send a request. Let's say a student sends a request for something on how to make a bomb. Okay, hopefully not in my school. But a student sends this request. The request will go to the proxy server, and depending on the settings, it might just stop it there and say no, that's a website we blocked. Alternatively, it might send a request. You get the request, you get the reply back, and it will check the content before passing it on. Before not passing it on, sorry. So it acts as a wall in many ways. So I say, can I have information on bombs? This will either just say no, or it will go get the information, bring it back, look at it, maybe for keywords, and it'll say, no, you can't have this information. However, if I want to go and look at Extreme Papers website, can I look at Extreme Papers? Yes, you can. I'll go get it for you, it will go get it for you, and then it will bring it back to the proxy server, and then it will come back to me here. And the proxy server will give it to me here. So let's go back to the question. Describe the role of a proxy server when a LAN is connected to the internet. So the role of the proxy server is to act as a web server that can protect or act as a wall between the users and the internet. Okay, so you'd want to explain this in more detail. Yeah, so for example, in order to block or restrict unwanted or undesirable content. Okay, so this is one of many answers. So it's a web server that acts as a wall or acts as a barrier, buffer. We'll go with buffer because that's the one that's in the answers here. Acts as a buffer between the users and the internet in order to block or restrict unwanted content. So we've got 3 marks there, but you might have other things like it might be to do with caching. So a cache is where you save the pages already. Maybe there are common websites that are accessed by everyone in the school, so the server could have a cache. It could keep that page ready and just pass it to the computers as they ask. So it knows that 50 people are going to try and access this one page. So rather than send 50 requests, it could just request it once and then send the cached version. We can also use it for, so we could have, caching. Caching common web pages to speed up requests. We could also have it for the school wants to, or a company wants to monitor internet usage. So by having this thing that's sending requests for us, we can keep our own records, and we can keep an idea of how the internet is being used. So maybe in the school, maybe we want to get information back on how much time is being spent on music sites for YouTube, compared to how much students are studying. Likewise, if we have the names of individual people logging in, we can see which students are trying to perhaps access websites or how they're using their time. Depending on where you live, this may be considered ethical or unethical. Anyway, so that should do us for that question. So the important one, I think, would be, the better answer would be acts as a web server and acts as a buffer between the users and the internet in order to block or restrict unwanted content. So let's move on to question 6. Susan uses a memory stick to transfer her work from school to home. Give 3 reasons why memory sticks are often preferred to CDs for storing work. So again, we have 3-mark question, and it says specifically 3, so make sure you give 3 answers, even if you're putting in just a bit of a guess. So 3 answers. So first thing, we have to be clear on memory stick. What is a memory stick? One of these, a USB drive. So a memory stick versus a CD. Hopefully you all know what a CD is. So we have to just give 3 basic ideas as to why memory sticks are better. So when you get this kind of question, if you can't think of an answer, just think about what you do in real life. Would you use a CD or would you use a memory stick? Try and think about why would you do that. So there are a whole bunch of answers that we can have here, but let's stick a few of them down. Probably the best one that comes to mind is that USB drive, I'll use the correct terminology, memory stick is less likely to be damaged. So CDs are pretty fragile. As someone who often, or I don't really use CDs anymore, but as someone who has often left piles of DVDs outside their boxes, I can tell you that they often get scratched and ruined very, very easily. So you've got to protect them, keep them in boxes, to keep them safe, whereas pen drives are much less likely to be damaged. In a similar fashion to what I was just saying, I don't use CDs anymore. In fact, a lot of computers now, they just simply don't have CD drives. I opened mine up the other day by mistake, and I think it's been more than a year or so since I've ever put anything in my CD drive. So a lot of computers don't have CD drives anymore, but most do have USB drives. I mean, be careful with words like all. Depending on the examiner, it's better to be safe. So say words like most, or a lot of, rather than all computers don't have CD is not technically correct. All computers have USB drives. Again, is not technically correct. So be careful with that, so that you don't lose points over silly little things. The other thing is transferring to CDs takes considerably longer than it does when transferring from a memory stick. So faster data transfer when using a memory stick. Okay, and again, be clear. Don't just say it's faster. Okay, because if you're not specific enough, you're not going to get the points. So you've got to give reasonably full answers. So faster data transfer when using a memory stick over a CD. And make it clear which one you are talking about. Because people often lose marks by saying it's faster. Or it's faster, it's got faster data transfer, but they don't specify if they mean the CD or the memory stick. Again, you'd probably be fine, but if you're aiming for high marks, you want it to be very precise. Alright, so there are other answers we could put in there. It's easier to carry a USB. Oh, it can store more data. That's an important one as well. Store more data. And yeah, most USBs now are 32 gig, other things like this. You can get really large size memory sticks. Much more than you can fit on a CD. Okay, good. So 3 marks should be fairly easy. Number 7. So 7 is one of these questions that comes up quite a lot, but is a bit of a throwback to the past. That said, it's sort of leading into programming and is quite useful for understanding how programs work. So a floor turtle can use the following instructions. So these are the only instructions that we can use. We can't use anything else. Okay, so often there's a repeat or something in here. We don't have that, so we can't use it. And we have to complete our list of instructions. Now, if you're wondering what this is all about, you could try this website, transom.org software/logo, and you see we've got, this is an online one. A floor turtle is more a physical one, but this will work fine. So we give this instructions like forward 10, and it will draw depending on what we tell it to do. So right 90 means turn 90 degrees. Notice when I turn 90 degrees it doesn't draw. Forward 5. Now one of the important ones that always comes up is pen up, which raises up the pen, which means it's going to stop drawing for a bit. And then if I do forward 10, it'll still move forwards, but it won't draw. And if I want it to start drawing again, I've got to go pen down. And then forward 4. Okay, so pen up, pen down. Let's go back to the test then. So in the test we have forward, backwards, left, right, pen up, pen down. So at the start they're going pen up, it's going forwards 50, it's turning right. So, but before we go anywhere, we have to tell it to put our pen down. Okay, so we're going to have pen down. We're already facing that direction, so we're then going to go forward 70. Sorry, my 7's a bit broken. Forward 70. Okay, and then we've got a blank space, which means we're not going to have our pen down, so we're going pen up. And again, forward 70. So that means we're doing this empty forward space. Once again, pen down. Sorry, I've got a keyboard cover on, I'm going to take it off because it's getting in the way. Pen down, and then forward 40. And once I get to here, I want to turn. So it's not north, south, east, west. So I'm already facing this direction. So I'm going to be turning how many degrees? Yep, so I'm going to be turning to the right 90 degrees. Okay, then forward 50. Right 90 and forward 80. Other questions like this often have repeats, so often the last section will be a repetition, and you would include them in the start repeat and finish repeat. They don't have it in this one, but most of the recent tests have a repeat section. Okay. So yeah, we just need to do as many as we can. Again, 5 easy marks. If you can learn this, it comes up a lot. It's worth knowing. So, question 8. Describe what is meant by a blog and a wiki. So, again, there's a certain amount of knowledge here, and there's varying answers. But a blog would be something like this over here. So let's see, one of these. Okay. So this is something written by someone, their personal journal perhaps, or some personal information about their life, and he's talking about his life in China, or you'll get a maths blog here, and he's talking about something to do with maths, I assume Pi Day, which happened very recently. well, at the time of making. And so yeah, these are more like personal weblogs, online diaries, opinions, other things like this. Whereas a wiki, so this is the Minecraft wiki. Minecraft is awesome. If you don't play it, you should try it. So this is a Minecraft wiki, which is giving us more information. It's more content based, and it's less opinionated. It's more factual. So when we're comparing the two, that's a lot of what we're looking at. Also, generally, a blog is going to be made by a single person. You do get, say, like a single company doing a blog or things like this, but generally speaking, blogs are like individual, whereas wikis are edited by multiple different users. So many people are contributing. These also are usually, the blogs are also usually chronological. So they're much more based on time and time-based, whereas these are ordered in terms of information and content for a wiki. So let's go back to the question. So a blog, what is meant by a blog, a wiki? So again, there's varying answers, but we could say a blog is a personal journal, often ordered chronologically, it's by a single user. It's often used for giving opinions and personal experiences. Okay. On the other hand, a wiki is a source of information on a particular topic. For example, Minecraft. It is usually edited by multiple users and ordered in terms of content. Yeah. Okay. You could add in something about because it's got so many users, it's not entirely reliable for a wiki. But again, this is sort of being proven to untrue these days, so be careful with that one. Okay, anyway, these are probably more than you need, but it's always better to write a little bit more and get the right answer, or make sure you have the right answer, than to rush through it. You've got plenty of time for the exams. If you've studied well, take your time and do it. Write as much detailed information as you can. Be specific. Is one of the most important things for this exam. Okay, now on to question 9. Tick true or false next to each statement to indicate if it's an example of online processing. So again, it's not a hard question, but you're required to do a bit of thinking here. So online processing, and the alternative here that it's really thinking about is batch processing. So we're sort of saying which one of these is batch and which is real time. So online. So online is where things have to be happening. You have to be connected and having inputs and outputs continuously. Whereas batch we can do it all together, and there shouldn't be any required additional inputs or outputs to the system. We'll see as we go through these. It'll maybe become more clear if you don't know this already. So, withdrawing money from an ATM. We'll call that A. So when we need to get money from the ATM, are we going to have to input, or is the computer going to have to receive additional inputs or outputs to be able to complete the request? And the answer is, of course, yes. So we're going to have to enter PIN numbers. It's going to have to check semi-immediately in real time to see whether our PIN numbers are correct. It's going to have to query the database to see if we have enough in our accounts. There's going to be lots of other additional inputs or outputs that we have to have. So it must be online processing. B, producing utility bills. So utility bills is a very standard batch process. So it's going to be false. So utility bills, we gather them all together. We process them at once, probably in the evening once everything's finished. We don't need any other information. We just need to move numbers about that are already in there, put them onto the bills, print them out, and there's no need for any interaction. So utility bills are just created straight off. So it would be a batch process. Booking a plane ticket. When we book a plane ticket, let's imagine we have two people. I'm here in Jakarta, and someone else is in Paris, and we're both trying to book a ticket for the same flight. Now, if it was batch, then we could both book the same seat on the plane, and we wouldn't know until later on that it was double booked. So what we have to have is online processing, so that it's constantly updating the system, and it's constantly changing and checking other things, so that if I book the seat, then he cannot book the seat, or vice versa. So this is going to be true, as we need real-time inputs. Oops, sorry, C, not A. True. Okay, and finally, producing payslips. So again, exactly the same as utility bills. These are all the information is already in the computer. It works it out. It prints them out. It's going to be a batch job. Okay. Let's have a look at number 10. So describe three types of test data. We have normal, abnormal, and extreme. So I think this is from our systems analysis part. So this is in our testing of the systems to see whether they work. So three types of test data. Normal test data is test data that is normal, which means that it's within the specified range. So let's think of it in terms of numbers, because it's easier. Let's say, I'll put it above here. Let's say a user can enter a number between 5 and 20. The user can enter a number between 5 and 20. So 5 is the minimum number. If it's less than 5, it's bad. If it's more than 20, it's bad. Let's say this is the number of students in a class. In the school, the maximum is 20 and the minimum is 5. So normal test data would be data that is within that range. So it must be between 5 and 20. However, you'll see in a minute, we don't want to say 5 or 20 here. It's technically okay, but that's one of the other two. So pick something in the middle, just to keep it nice and clear that it's normal test data. So let's say we would pick normal. Let's have 10. Okay, so 10 or 15 or 18 would be normal test data. So data that is within the range. Data that's within the range. This should be fair enough. You might need to, again, explain in as much detail as you can. Abnormal data. So abnormal data, data in the range and appropriate. Let's say and appropriate. We'll see what I mean by appropriate in a minute. Abnormal, so if we have 5 to 20 as a range, abnormal is when it's just strange or completely wrong. So, for example, 4 would be abnormal in this case, or 21, or 0, or -1. And likewise, for normal, I was talking about appropriate. So abnormal data can be inappropriate. For example, if we are asking for a number, we can say, I don't know, frog. Yeah, we could just give it letters, or we could give it random characters that it's not going to expect. The idea would be to see that the system can handle these and that it deals with them appropriately. It doesn't try and use them. It should come back to the user and say, no, that's not right. Don't give me that. It shouldn't just crash, or it shouldn't just try and use what it's got, even though it's wrong. So we could say that data that is not in the set range, or which which has wrong characters or data types. Okay. And the last one is extreme data. So this one's a little bit different. So extreme data is ones which are on our boundary. So again, we have 5 and 20. So in this case, extreme data could be 5 or it could be 20. So data that is at the limits of the range, but still correct. Okay, so we're not using abnormal data here. We're using normal data. Oops. We're using normal data at its extremes. I'm not sure why this is. There we go. We're using normal data at its extremes. So I can clear these up. Put this onto question 10 where it should be. And we can get rid of these. Okay. So normal data, data that's within the range and appropriate. Abnormal data, data that is not in the range or which has wrong characters or data types. And extreme, which is data that's at the limits of the range, but which is still correct. So on to question 11. This one's quite a big question, so you've got to be careful. We've got 11 marks in there. So let's have a look at it, but a very important one, just simply on number of marks. So the head teacher of a school wants to build a weather station, and she wants to use a computer to collect these results. Describe 3 reasons why she wants to use a computer rather than allow students to collect the results. So here we have to, again, put ourselves into that situation. So why, if you were a student and your teacher came to you and said, we're going to have students measure the weather, okay, what things would go wrong? Why wouldn't you want to do it? Would you be happy to stand outside 24 hours a day, 7 days a week, looking at a thermometer? Probably not. So computers are good for boring tasks. They're good for monotonous tasks. So put yourself in that situation. Why would it be better to use a computer? So let's start with computers can take readings 24 hours a day, 7 days a week. While it would be, you could say, dangerous for the students, it would be 7 days a week. Well, it would be difficult to get students to do that. Other things, computers can check more often, they can check more frequently. I'm having a bad time with my keyboard today. Computers can check more frequently. Computers can check more frequently. What else would be a problem, or what else would be a good advantage of that? A human looking at a thermometer is not very precise. So a computer with a sensor is much more precise. So we could say that computers can take more accurate readings. Other similar things, humans or students even might forget to take the reading. So humans are very useful, but we are quite unreliable for these monotonous tasks. So computers are much better. Other things you might have is the intervals between readings can be more regular. Computers can analyze the data, more, can analyze the data right away. Yeah, so there's a whole bunch. We only need 3. One mistake a lot of students I've seen making in this sort of section is to put down the same answer 3 times. So they phrase it slightly differently and they put down the same answer. So be careful. Make sure that when you have distinctive options available for your answers, put down the distinctive answers. That way you can be sure that you're not crossing over with your questions, because you'll only get 1 point for one type of answer. So be distinctive in your answers. Okay, part B. The results will be stored in a spreadsheet. The head teacher wants a word processed report. The report will contain a description of the weather and will use the spreadsheet results. Describe how the report will be created. So we're just going to talk about the steps that the teacher might make. Put A in here. So we're just going to talk about the steps that the teacher might take on part B. So one important thing here that a lot of people make a mistake on is to do with things like Spreadsheet and word processor. So it's very important that you do not use brand names when you are giving your answers. So for example, if you were to say the student opens Microsoft Word, then you will not get the point. So you cannot use brand names in your examination. The reason for this is they cannot possibly know every single piece of word processing software. For example, perhaps in China there is a Chinese word processor that's more popular than Office. If a Chinese student was to put down that program, the examiner would have to go and investigate what it was, which is too much work and it's too difficult because there might be small word processors that no one can find. So in that situation, they've decided and they've said we cannot use any brand names at all. So you've got to say word processor, you've got to say spreadsheet. You cannot say Microsoft Office and other things. Anyway, so let's just put down the steps that we need in order to be able to do this one. So we've got the data going into a spreadsheet. So we could say the data on the spreadsheet will be saved. The data could be analyzed. Sorry, I always got the spelling mixed up on this one. The data could be analyzed and made into charts and graphs. The user could open a Word processor, for example. We're not going to say remember, don't put in Microsoft Word or anything. I think if you say, for example, Microsoft Word, you'll be okay. But make sure you say word processor. The user could open a word processor and import the graphs and charts from the spreadsheet. The user could write about the charts and graphs. The user could format the page to make it suitable for the report. Okay, so that's probably a bit more than you need. But I think that contains most things. Oh yeah, the user could insert pictures into the report. Okay, so it's actually quite a simple question, but you've just got to make sure you're doing it in a succinct and sensible way when you answer. So let's go on to part C. Oh yeah, and always keep an eye on the number of marks. So make sure you got 5 marks in this part here. I'm pretty sure we do. So part C. Spreadsheet data is often used for modeling purposes. Give 3 reasons other than reducing danger why computer models are sometimes used rather than the real thing. Now, as someone who's marked a lot of these exams, things like this, other than reducing danger, are often just skipped. So people read the first bit and they somehow skip the middle bit and read the last bit. So you've got to be careful and read the question and follow what the question says. So we can't talk about reducing danger, which is the most obvious answer. So they're trying to trick people who have only learned the most obvious answers. Not trick, but test, effectively. So a lot of people get confused. What is computer modeling? In many ways, I think the spreadsheet's a bit confusing here for some people, but spreadsheets can be used. But modeling could be a whole bunch of things, like if we were going to build a building, then we would first use something like AutoCAD to design the building before we built it. Likewise, there's some things we can't model or we can't build in real life. In science, people are often trying to deal with, what will happen to the stars, to the cosmos in hundreds of millions of years' time. So we can't just sit down and wait for those things to happen in real life. We want to predict them beforehand using a computer model. So what we do is we have the computer act out what it thinks is going to happen in real life for us. So we need to give 3 reasons, again 3 reasons, 3 points as to why computer models are sometimes used rather than the real thing. Oops, sorry, it should be 12, it should be C. C. So let's say we could say that in some cases it's going to be cheaper than making the real thing. We can also say that things like, so rather than making the building, it's cheaper for us to use the model than make a full building. This is, again, be specific. I think you get the point for cheaper than making the real thing, but especially if this is especially true if there's a mistake in the building. So let's say we were building a building and there's an error, then it's much cheaper than us starting again. But in this case, we're talking about spreadsheets, so we can't talk about buildings. So I apologize if I'm causing some confusion there. So spreadsheet data is used for modeling purposes, so it's cheaper than making the real thing. So let's say I have a spreadsheet modeling where my cars are going to go. Let's say I work in the transport industry and I have trucks and cars that transport things around the country. I can work out fuel calculations, I can work out other calculations to see what's going to happen without trying it in real life and seeing if it works. And that way I can work out the most effective thing. So it's cheaper than the real thing. What else could we say? If I was modeling the solar system and what's going to happen in the future, again, this could be done mathematically on a spreadsheet, then it's the results can come faster than waiting on the real thing. Other things, yeah, again, the same one. If we're doing the real world thing or the universe, it's too big for us. So the scale of the real world events, or the scale of the real world, may be too large to follow. Again, going with the transport thing, it costs less to make changes. So if I model it on the spreadsheet first, I can see what problems are going to come up and I can make those changes. Or if again, I know we're talking about spreadsheet, but it's sometimes easier if we think of the building. If we're thinking of the building, we might be wasting money on buying materials and things like that, when we could make a model first, discover the problems, and then make the changes for when we are making the real thing. Yeah, so there's a lot of answers around that area. As long as you get one of them. So real thing might be wasteful. Again, these are sort of the same answer, so you can pick ones that are not too similar. And probably you want to explain your answers in a bit more detail as well. Okay, so anyway, that should be enough for that one. So let's have a look at question 12. A supermarket uses POS terminals. The stock levels at the supermarket are updated automatically. Describe the steps involved in updating the stock level of a product when the barcode is read. So first step here, of course, is we have to have some idea what a POS terminal is. So put simply, it's one of these sort of things. So if you Google POS, you'll get a wrapper, but you'll also get mainly these images. So point of sale, it's an area where we're selling stuff. So we're specifically talking about barcodes. So we're looking at a barcode reader. Be careful because these things are more like your electronics funds transfers at point of sales. So we're looking more at the barcode reader in this situation. So the supermarket uses these terminals, and the stock levels in the supermarket are updated automatically. So what are the steps that are going to happen? Well, okay, first of all, the barcodes will be read, and once we've got the barcode, so possibly by the barcode reader or by the POS terminal, that code will then be taken. The code will be taken and compared with the database, or I won't say compared, and will be found in the database. The records in the database will have its stock level deducted. So we'll go to the records in the database and we'll take away 1 from it because we've sold 1 at the terminal. So we have to take away 1 from our stock levels in the shop. Okay, but then we're going to have to compare the new stock level for the product will be compared with the auto reorder level. So the store will have set a certain amount. For example, Coca-Cola, if there are only, let's say, 100 bottles of Coca-Cola left in the shop, then an automatic order will be sent to, well, either to the main terminal or to the Coca-Cola company, depending on the system's organization. But so there'll be a set number. So each time the product loses 1 or whatever number, then it will compare it with that reorder level number. If the reorder level number is higher, say, than the product level number, then it's going to create a new automatic order for the stock. Okay, so the record in the database will have its stock level deducted. The new stock level for the product will be compared with the order. If the stock level is less than the reorder number, new order will be automatically sent. Okay. Yeah. So, and then you could have something like, yeah. So we've got the stock levels updated, and then okay, we're going to read the next product will be scan at the POS. Okay, so that's us back to the beginning again. So we need how many marks here? Let's check. We need 5 marks. So the barcode will be read by the terminal. The code will be found in the database. The record in the database will have its stock level deducted. The new stock level for the product will be compared with the reorder level. If the stock level is less than the reorder number, a new order will be automatically sent. Oh, and I forgot one thing. So we don't. If someone, let's say, I deducted the Coca-Cola and a reorder has been sent, the next time Coca-Cola comes through, we don't want a second order to be sent. So we want the stock level will be updated. So again, that will depend on the shop how they're doing that, but we don't want to have it that every time a bottle of Coca-Cola is deducted that 17 orders are sent. We want to have it marked that an order has already been sent. So that might be a Boolean or something like this. Anyway, and then the next product will be scanned. Okay, so, but yeah, we've got all the points there, or at least 5 of the points. Okay, number 13. So 13 is a spreadsheet question, which seems a bit odd because this is the theory exam, but they will include some, especially when in the newest examinations, they're going to be including more practical questions in the theory exam and some theory questions in the practical exam. So watch out for that when it comes along. Anyway, a shop owner uses a spreadsheet to calculate his profits. This is part of the spreadsheet. Give a cell reference that contains 158. So a cell reference is simply the column and the row. So 158, let's find it. Okay, 158. So it's in cell reference C3. Okay. Again, easy enough, but it's knowledge questions, so you have to remember it basically. Give the cell reference of a cell that contains a label. So label effectively means some kind of text. So any of these cells that doesn't contain a numerical value, we could pick any one. So let's just say for this time round, we would say, okay, easy one, A1. So A1 contains producer, which is text, but we could also have any of these really. So any of these, but not the numbers. Okay. Write down the formula in cell F5. Okay, let's see. Let's find it. F5. Okay, profit. So we have to work out the profit that's going to go in here. So we're going to take the selling price and we're going to deduct the cost price. So that will be let's put it down here. So C is going to be equals, so we've got formula, equals the selling price, which is sorry, I can't see it here, E5, I hope that's right, E5, and it's going to be minus the cost price, which is D5. So equals E5 minus D5 will be the formula in here. E5, D5. Yep. Okay. Again, you just have to know your spreadsheets at this point. It's more the practical side. Okay. Write down the formula in cell G2. G2. Where is G2? Okay, G2. So total profit. So we're going to multiply, I would think, the number in stock and multiply it by the profit. So that would be C2 multiplied by F2. Yeah, let's go with that one. So C2 equals C2 multiplied by F2. Okay, and let's just double check. Always double check these things. The amount of time people make silly mistakes, and I'm aware I might make some mistakes along the way on this test, but it's one of the biggest reasons for people losing marks. So C2 F2 is correct. So go back, check your answers. And that was D. So we're on E. Formula similar to that used in cell G2 have been used in cells G3 to G6. These were not typed. Describe how these were entered. So you could say, so what we're going to be talking about here is going to be relative versus absolute. So you could mention the word relative, it might help you get the point, but I think they're more looking for a description of what was done. So we could do it by, so on G2, we could do it by finding the handle in G2 and copying it, dragging the handle down so that it's copied filled down. Or we could copy the ones in G2 and paste them in below. So do a relative copy and paste of cell G2 into the other cells by dragging the handle down. Okay, so do a copy and paste of the cells by dragging the handle down. Yep, so hopefully that will get us our marks there. We won't say the other cells actually, and let's be specific, into G3 to G6. Again, it's better to be a little bit more precise than to lose the points because of not being precise enough. Okay, on to question 14. John owns a small company. He wishes to replace the existing computerized system with a new one. He's employed a systems analyst to plan this. So again, this is a big systems analyst's question from that particular unit, and it's worth quite a lot of marks, so we've got to be careful. Part A. Iqbal will need to collect information about the existing system. Describe 3 methods he could use. So we'll talk about the 3 methods and we'll cover a few advantages as well, perhaps along the way. So we have the system, it's already working in our company. Let's say it's a shipping office. So in the shipping office, it's already doing its thing. We need to find out what's going on there because we're a systems analyst. We don't work there. We're a consultant. We're coming in and we're going to change over the system. So we need to find out some things about it. So there's loads of ways we can do this, or there's 4 main ways. And we'll get 3 answers, so we need to get 3 of them. But we could start with having an interview or interviews. we could talk to people and see interview of users, talk to people, see what they say they're doing with the system. This is quite good because we can follow on questions depending on their answers, as opposed to the second one, which would be questionnaires. Okay, so second one, questionnaires for users again. So you would write out questions for the users, give it to them, they'll answer it and send it back to you. This is quite a good way. You can ask lots of people at the same time and they can answer in their own time. If you're doing online questionnaires as well, the results can be automatically collated together for you, and it can save you a lot of time that way. Question 3. Question 3. The third one is documentation. So the system should already have, if it's been done properly, as you'll know, in the systems analysis cycle, we have to produce documentation. So if that was created for the original system, it will or should still be there. And you can find out how the system should be working. The downside is that systems tend to evolve over time and they change, so the existing documentation may not be kept up to date. Likewise, the reality of the system might not fit with what the documentation is saying. So number 4 as well, which is probably one of the best ones, is observation. So a lot of people say things and they tell you what they do, or the documentation says what people should be doing. Observation is one of the most important ones because it lets us see what people are actually doing. So a lot of the time people will say they're doing something, but in reality they're doing something else. So that's one of our most important ones, is observation. So you want any one of these 3 for the answer. Part B. Iqbal has completed the analysis of the existing system. Describe 3 items of file structure which he would need to design for the new system. So this is a bit of an odd question because it makes it sound as if we're automatically going to be using a certain type of system, probably a database, by the way the question's phrased. And it's not really told us that before. However, let's think of it as a database in this case, because it's our easiest way to answer the question. So if we were making the database, if we were making this new system with the file structure, what would we need to have? So you're making your database. Of course, the first thing one of the first things you've got to have is going to be your field names. Now, once I've told you that, everything probably falls into place and you can tell me the other 3. But identifying it is actually quite difficult at that point. Maybe not the best of questions or the clearest of questions, but it's okay. So field names, field types, or personally prefer to call them data types. We could have properties like the field size, or decimal places, etc. We could have the rows we're going to have. Rows, let's call them validation rows. Any one of these would be fine, or maybe something like the primary key So you're thinking, if we had a set of data, how would we organize it? In this case, obviously, in the database. So, part C, and remember, if you don't get, say, part B, take a guess. If you're wrong, it's okay. But try and answer the next part. Just because you can't do part B doesn't mean your part C is impossible. Often they're separate entities about the same topic. So anyway, after the system is designed, it will be implemented. So we're in the implementation phase. We're going to be switching over the system. So describe each of the following methods of implementation. So in our shipping company, we've got the old, let's say, database, and we want to jump to using the new database or the new system. So how could we do this? The most obvious one, and I guess the simplest to plan in some ways, is direct changeover. So that's when we turn off one system and we start the new system in its place without any crossover. So say immediately change from the old system to the new one. Okay. Parallel. Oops. Oh dear. Terrible typing. Parallel running. So this is where we have both of our systems running at the same time. So we have our first database and our second database both running at the same time. This is good because it's reliable. If the new system breaks down, if we're doing direct changeover, that's going to be disastrous. The new system breaks down, we've got nothing. With parallel running, if the new system breaks down, we can instantly switch back to the old system. So it's a really safe way to do it. Not always possible. It is expensive. If you're going to have to if you're having people doing double the work, you're going to have more people, or pay them for doing longer hours possibly. Likewise, if you were planning to use some of your old technology, for example, if you were just installing a new database, rather than bringing in a whole new server or something to deal with it, then you would have to have double the equipment running. So it's an expensive way to do things, but it's quite a safe one. Phase implementation. Okay, so phased implementation is. Let me put a full stop down there so that we can see what's going on. Phased implementation is where we implement the system in stages. Okay. Is in stages. So the system is implemented in stages or part by part. That's what it says in the answer key. So the system is implemented in stages. So for example, we might have a database and we might have a front end and we might have a printing system, a new printer system. So in this phased implementation, we would first say introduce the new database. But we would keep the other things the same. Then once that's worked over a period of time, we would then change the printing system. But we would still keep the front end to be the same. And then finally we would change the front end once the other parts of the system had proven themselves. It's a nice idea. It's not always technically possible, as different parts of different systems don't always fit together. But when you can do it, it can be quite a good way to do the changeover. And finally, we could have, or we have, scroll down, pilot running. So this is where we run a pilot system, which is not a man in an airplane, but a one-off or a one trial area. So, for example, in our shipping company, maybe first one part of our company, one department, so maybe the human resource department, will change over to the new system first, and they'll check it out, they will fix any problems, and then we'll move it on to another branch. For example, maybe the stock department or the shipping part, and gradually each department will take over the system, but only a department at a time. So this is different from phased implementation. Phased implementation, we're putting parts of the system out at a time. In pilot running, we're running the whole system, but only in different parts of the company. Okay, so the system is implemented one branch at a time. One branch section of the company at a time. Yep, so be careful with these two as they can be quite similar. Okay, now we're on to question 15. So we're going to be talking about these three things here: OMR, OCR, and MICR. So obviously they're checking here to see how well you know your input devices, and they're just giving you the acronyms so that you have to figure things out from there. So it's a bit of a test of your knowledge and a bit of your test to see if you know how these work, not just that you can name them. So let's start with OMR. So OMR is optical mark recognition, which is like this. If you've ever taken a little test, you put your pencil marks on there. They're going to be read by the scanner, and then the position of the marks are going to be identified by the computer, and it will be able to calculate your score based on that. So let's take that one down. So OMR. Oops, I've got an extra space there. Oops, these should all be in the one so that we have the right number. Hang on a second. There we go, 15. OMR. So we're going to say that marks are made using a pencil, and then read by the scanner. The position of the marks are used to identify the answer given. Okay, so marks are made using the pencil and then read by the scanner. Okay, that's the first part. Second part, don't forget, give an example of an application where each might be used. So our obvious one here for OMR is almost always for multiple choice questions. So school exams that are multiple choice. So something like that would work quite well. I'm trying to think of other, really I can't think of other regular places that it's used. Depending on where you live, in the UK, for example, it's used for things like the National Lottery, but I really can't think of any ones apart from exams that it comes up very often. But if there is one in your own country, then you can go for it. as long as you're clear. The second one is OCR, which is up here. I lost it. It's OCR, which stands for Optical Character Recognition. So mark recognition, and this one is optical character recognition. It's really good if they ask you and they just give you the acronym. It's really good if you can change it out into the full words. It shows them early on that you understand what's going on, at least a little bit, and that you're not just making up some fluff. Okay, so optical character recognition. The text is going to be, example is going to be a passport. So this scary cat here is Russian cat. These characters down here are going to be ran through a scanner, and these images are going to be compared, the character images are going to be compared with a set on the computer, and it's going to identify what the words and numbers are by using other similar pictures. So it's like comparing the pictures to find out which letter it is that you've used. Probably it will then be converted into text on the computer. So let's say you go to border control, they run through the passport. These will then be read onto the machine as text. So it's a way of taking physical text on paper and putting it into the computer. So our answer here for OCR would be the text is read by the OCR is read by the scanner, and compared with the character set on the computer. It is then converted into text for storage or use in other software. Okay, so something like that would probably be a reasonable answer. You say, and let's be a bit clearer here, sorry. Scanner and the images compared with the. Okay, so it's kind of like, yeah, it's taking a photograph of it and comparing the photograph with other photographs of other letters to find out which letter it most looks like. So things like passports, there's probably, I'm not entirely certain, but I imagine there's an agreed upon font that all countries are using so that it's clear and easy for us to move between countries. Okay, and our last one then is MICR, which stands for Magnetic Ink Character Recognition. So Magnetic Ink Character Recognition, MICR. Most commonly, this is going to be used on checks. Again, I can't really think of many other places that it's been used. Oh, which reminds me, sorry, I forgot. See, you got to be careful. I forgot to answer this one. Commonly used in passports. This is how the difference between an A and an A star. So let's go back. Magnetic ink character recognition, which we use for checks. I'm going to put that in at the end. So what's going to happen with magnetic ink there is the characters are read by a special reader, by a magnetic reader. And they're compared with the characters in the computer again. It's then converted into text for use with other software. Okay. So yeah, the common example, an example might be bank checks. Again, I really can't think of any other common use for magnetic characters these days. But please, if you think of any, let me know. Okay, good. So I think that's us with this question. A, B, C. Okay, so let's have a look at question 16. A company uses robots to manufacture cars. So first of all, let's be clear on what robots are. We're talking about this kind of thing rather than it being the android human-like robots. So in a factory, we have this line here making all these different cars together. So a company uses robots to manufacture cars. Give 3 advantages to the company of using robots rather than humans to manufacture cars. So the first thing we have to be very clear on here is that we're talking about the company. If you just throw out some general advantages of robots, some of them are going to be true, but we need to focus on the company rather than in general. So you will lose marks if it's not focused on the company. So be specific and also focus on manufacturing as well. Humans are great, they're very useful, can be quite creative, but when it comes to certain tasks, we tend to be less precise than robots. So, you'll often get handmade goods are sold for more because they have a uniqueness to them. Everyone is different. But with robots, the big advantage is that everything they produce is going to be the same. So, the same thing every time. So this is a really big advantage, especially when, say, you're selling things all around the world. Some parts will be made in different countries, and when it gets to be assembled together, you have to make sure everything fits. There can't be these small differences, otherwise you're going to have problems with the machine. Likewise, if you're sending out spare parts to somewhere else, you want all of the spare parts to be a perfect fit. You don't want to have to be hammering in spare parts and things like that. So having them produce the same thing every time is a really big advantage. The other one that people often put down first is going to be it's cheaper. This is not going to get you the points. So you have to be specific in your answer. So it's cheaper over the long term because robots don't have to be paid wages. We'll see why that answer would be wrong in the next part of the question, because we're going to put it's cheaper in there as well. See if you can think about why. Okay, so robots produce the same thing every time. It's cheaper over the long term because robots don't have to be paid wages. Robots are more productive. They can work 24/7 and don't have to take breaks. So probably individually each of those three parts would get you some kind of an answer, but again, it's better to have diverse and detailed answers to make sure that you get the points. So yeah, robots are more productive, they can work more hours, and they don't have to take breaks. At least they might have to stop for maintenance, but not the kind of regular breaks that humans take. They're not going to have to disappear for hours on end or days before coming back. So the robots are always going to be there, and they're always going to be working. Other things, you could maybe have things like robots can work in dangerous places. So if you're building cars, there's going to be a lot of sparks flying around. There's going to be a lot of heavy things being lifted, so it can be quite dangerous. So robots can work in these places, whereas humans can't. So you can use the space more efficiently, I guess, but you can also you don't have to worry as much about people being injured and then your company being sued and things like that. And other ones, yeah, you could say something about industrial disputes with humans and things. Again, I would say working in dangerous places and industrial disputes in this case is a bit weaker because, robots can be the cause of industrial disputes in some cases. So, okay, but they are possible answers. I'd say stick to these other ones first before you go down that road. Okay, so let's have a look at B then. So B is just the opposite side of the coin. What disadvantages do we have from robots? So let's start with this other one that I sort of challenged you to earlier. It's cheaper because robots don't have to be paid wages. Why would it be wrong just to say it's cheaper? Well, the main reason would be that robots are very expensive. High startup costs. So yeah, robots are really expensive. You have to invest a lot of money in building them. You have to invest in training staff. So while we probably would be getting rid of some employees because of the robots, other staff we wouldn't be. And so we would have to invest in training staff. We'd have to hire new staff or retraining staff to deal with the robots and maintenance, repair, other things like that, health and safety. So we need to watch out on that side. Other costings, repair costs can be expensive. So again, very similar. But the whole idea is that, if you buy your robots and they break quite early on, the costs could feasibly be higher. Most companies, of course, find that they work out cheaper in the long term because they get increased productivity and less breaks and things like this. But there is some element of risk to dealing with robots. They can be expensive to repair. Likewise, as we were saying before, humans are creative. They can deal with situations better. Whereas even with small changes, the robots will have to be reprogrammed. So yeah, even if there's like a small change, if you're moving a door handle a little bit to the left or right, then you're going to have to change the robots as well. And finally, maybe we could put something down about the weakness of robots in terms of if there's a systems crash, then all production would stop. So yeah, if there's a crash with the program, who knows how long it would take to fix. depending on how well the programming job's been done. There are some famous cases of programming going wrong, so yep, it can also have problems in that way. Question 17. I apologize if I get this name wrong, but Jasper and her family have 3 computers in their home. She wants to connect computers to create a network and access the internet. List 4 additional items she would need to set up this system. Your answers must include hardware and software. Okay, so let's have a quick look at the question itself. So we're listing. So we don't need to explain our answer. We just need to list 4 additional items. And one of them must be hardware, and one of them must be software. Everything else is really up to us. So hardware is, of course, the easier one here. There's a whole bunch of options that we could have. The first one would be from the computer itself. Most people who have computers, inside there's going to be your network card. So this will allow every computer or computers that have them to connect to different networks. It allows it to deal with incoming and outgoing traffic and so forth. Another item we might have, so if we were talking about making a LAN, we're often going to have a switch or a hub. So I wouldn't put 2 of these down, I would just put one or the other, a switch or a hub. A switch would be the more intelligent one, and quite frankly, the only one we would really use in a modern day setting, unless there was a specific reason for a hub. So yeah, a switch or a hub would work. Likewise, if we wanted to actually connect, so that would be to create the network in her home. So a switch or a hub for joining computers together on a LAN. But she's wanting to connect to the internet. So we've got our computer connected to a LAN, and then we want to connect the LAN to the internet. Most common way these days would probably be through a router. Although feasibly we could have a modem as well if we wanted to go back in time a little bit, or different setup. So those are all hardware though. So what else would she need if she was going on to the internet in terms of software? So the easiest one that comes to mind is going to be a browser. Now, looking at the marking scheme here, they also put down things like firewall, antivirus software, anti-spyware software. So again, these things are not necessarily requirements, so they don't really fit into the question of what she would need, but they would be strongly advised. So they're allowing those as answers, which is quite good. But we've got 4 things there. So a network card to connect the computer to the network, the switch to connect those computers together, a router to connect our network onto the internet via our ISP, and a browser as a nice piece of software so that we can then view web pages that we get from the internet. They also have down here things like cables, telephone lines, ISP, so you could feasibly have those, but I think the 4 most straightforward would be network card, switch, router, and browser. Alright, so question 18. An automatic washing machine is controlled by a microprocessor. Other than a temperature sensor, name 2 sensors used in the machine. So question 18 is a type of question that does come up a lot, and we're talking about microprocessor controlled devices. It's really good if you can learn this type of question because it does come up again and again. So Our first question is going to ask us, what type of sensors do we need inside this machine? So it's going to be a washing machine, it's washing our clothes, it's going to be checking the different variables to see what's going on, and it's going to be sending that information back to the microprocessor. So what variables do we have to measure? In this case, they've restricted us and they've said, no, you're not having the easy one, which is going to be temperature. So what other things might we be measuring in there? So washing machine, we're going to be dealing with a lot of water. So we probably want to have a moisture sensor in there. So we want to know if there's water flowing in or not, if the drum is empty or not. So we need probably a moisture sensor. Other thing is we have this moving drum in the middle that spins the clothes around. So maybe we want to have a motion sensor to detect if it's moving or not, if it's fully stopped, for example. A lot of washing machines won't let you open the door until the drum has fully stopped. So you might have something like that. Other ones, you could possibly have a pressure sensor. I would assume for water pressure perhaps, or to see if there's any kind of build up inside the system. So any of these three would probably be okay, but I would suggest that the first two, moisture sensor and motion sensor, are probably going to be our best bets in this case. Okay, part B is when we start getting into the heavier stuff a little bit. Explain why computers are unable to read the data directly from these sensors, and name the device which would enable them to do so. So we're going to have to just do a little bit of knowledge and learning here. So those of you who are also doing physics will maybe find this one a bit easier. So we're talking about analog to digital. So the signals in the real world, I guess, come in these sort of analogs. They're continuous. There's not really, as we see them at least, there's not really a break in between them. For example, light, unless we go very deeply, we're going to see it as a continuous wave, as will sound be seen as a continuous wave. But computers don't think that way. They think in digital. They think in on or off. So what we have to do is measure in segments and say whether something is on or off depending on its position. So, for example, in this very simple example, we're saying at the bottom, if the wave is touching this point, then it's 0, 0. If the wave is touching this point, then it's 0, 1. If the wave is touching this point, then it's 1, 0. And if the wave is touching this point, then it's 1, 1. So this would be obviously, you'd probably have much more detail. You'd have lots and lots of lines depending on the quality of the digital readout. But you'd have to convert this type of signal into this type of information for the computer, or this type of data for the computer to deal with. So, explain why computers are unable to read directly from the sensor and name the device which would enable them to do so. So you could probably say something like, sensors read analog data, computers use computers use digital. To convert them, we would need what is called an ADC, which simply means analog to digital converter. So you probably get away with writing ADC, but it does help to write out the full wording just in case. Okay, so sensors read analog data, computers use digital. We need an ADC to convert the data, to convert the signal from one to the other. Okay, and C. So part C is where we kind of have to tie all of this together. So one of the key things here is that often you'll be asked questions B and C as one single question. This time they're separating it out for us, but let's think about how it all fits together. We'll include B in our answer, but we wouldn't get points for that, but just to make it clear this time. So we have a sensor and we have a microprocessor inside our computer. So the sensor will read in the analog signal, and the ADC will convert it to digital before it is read by the microprocessor. Okay, the sensors, sorry, that should be plural. The sensors will read in the analog signals, and ADC will convert them to digital before they are read by the microprocessor. Okay, then we've got these variables. We've got a variable from one of our sensors. We have we know that the temperature is at a certain level. So in this case, remember, we're thinking about a washing machine. So the microprocessor will compare the read in value from the sensor with a predefined value. So in this case, let's talk about temperature. So, because we are talking about temperature, sorry. So we should focus on temperature. My apologies. So again, I could change this back to single. So the temperature sensor will read in the analog signal and it will be converted to digital before being read by the microprocessor. The microprocessor will compare the value from the sensor with a predefined value or a value set by the user. So this is just saying that if the user has said, I want the temperature to be 60 degrees, so that's way too hot, but if I want the temperature to be, I don't know, for example, 30 degrees when I'm washing my clothes, then the sensor will already have this 30-degree value in there already. So it will compare the sensor value with the value that the user wants. If the sensor value is too low, the microprocessor will turn on the heating system. If the value is the same as or higher than the preset value, it will turn off or leave off the heating system. Okay, so that's all we're really describing here. It's kind of like, think of the microprocessor as just a little man who's sitting there. He gets given a piece of paper with one number on it, and he gets given a piece of paper with another number on it. He just compares them together. If one is bigger than the other, then he takes some kind of action by pressing a button or something to turn something on or to turn something off. He doesn't understand it's heating, he doesn't understand it's anything else. He's just comparing these two different numbers and following a predefined set of instructions. So anyway, like I said, this one comes up quite a lot, so it really does help if you understand how the sensors and microprocessors work together. So great. So we're now on to our last question. So well done if you made it this far. Describe two methods of data verification. So again, we're jumping back to systems analysis again. So it's a very important area to keep an eye on. And this time we have to be clear on the difference between verification and validation. So these similar sounding words have similar sounding jobs, and you'll often get questions about verification and validation. So the big error here would be to, of course, describe validation. So validation, the wrong one, is when we're checking that our data types are correct, that we're using the correct matching of data for the system. Verification, that's the correct answer in this case, is when we're ensuring that the data from a previous location is being copied correctly as it is. It doesn't matter if it's valid or not, we are just copying over what it is that we want. Okay, so in this case we're going to have to describe two methods of verification. So let's see. So there are only two methods of verification. So we don't really have a huge amount of choice. So the first one is maybe the most obvious one, and perhaps we lose sight of it because it is so obvious. But this is just a visual check. So I'm copying, let's say I have a book, and I'm copying that book onto a computer. So the obvious way to check that would be for me to just look at it afterwards and read through it again. So visual check is where we say user makes a visual inspection of the data after it has been copied. Yep, so we would just be doing a check between our original document and the place that we've copied it to. You could say by comparing with copies, just to be clear. And then on the other side, the other option we have is called double data entry. So again, if we were copying a book into a computer and we wanted to ensure, we wanted to verify that our data was correct, one of the ways that we can do this, and it's a bit more sophisticated than the visual check, is to have two people enter the data. And both entries are compared together to ensure that they are the same. So again, this is two people working separately. They both copy the book in, and the computer checks what they've typed together to make sure that there's no discrepancies, there's no places where they are different. And that's a much more sophisticated way, but it obviously takes a good deal more. It takes double the time, effectively, to copy your data from one place to the other. And just as a final thing, notice that the data they're copying, it could be wrong. We're not checking for that. We're just checking that it's copied correctly. For example, I'm copying a book, and the book has bad information on computer science courses or ICT courses. So that information will still be copied, and it will still be verified because it's the same as what was in the book. We're not checking the contents of the book to see if the information is valid or is correct, which is what would happen in the validation section. So well done for making it to the end. I hope that was helpful for you in some way. If you've noticed any mistakes I've made along the way, please feel free to point them out below. Or perhaps you have some clarifications that you would like to add. Again, feel free to add them in the comments, and that will really help other people out. It's good if we explain things in different ways, because different things work for different people depending on their characters and style. So please send them in. Also, if you can, please check out our website. So it's examdebug.com. And you'll find hopefully more past papers there and other explanations. You can go in deeper to some of the parts that we've covered today as well. Great. So thanks very much for being here, and good luck with your exams.